Hi, Assalamualaikum. Today our group, which is group 6 from section 4, will present our PBL for algebra. The topic is design of water tank system and waste management facility. The group member include Anisha Fika binti Muhammad Nafi, AA 240341, Muhammad Shahrul Nizam bin Wahid, AA 240021, Putri Zulaika binti Otma Hadi, AA 240315, and the last one is me, Arbiana binti Anim, AA 240330. Our lecturer's name is Sir Zulafik bin Sazali. Today, I will present the introduction for our group, which is group 6 for our algebra PBL. Okay. Water distribution system is the most crucial issue in human history. Water distribution system refers to the system and process of delivering clean water from sources like lakes, rivers, and aquifers to homes, business, and industries. A good water distribution management ensures that everyone can consume safe water for drinking, cooking, and also hygiene. Besides, use the water for daily use like household needs. The excellent work made by this system helps a lot in minimize some waterborne disease because it distributes treated water to each of the house. The purpose of the water management systems is to protect the environment by a proper disposal waste. It can prevent from pollution of air, water, and land. Furthermore, it can reduce gas emissions from greenhouse that can change the mitigation of climate. Additionally, this system can improve public health safety because the efficient management of disposing the hazardous and non-hazardous waste. Arithmetic sequences are useful for modeling systems in water distribution. This method used in pipe network design by calculating the water pressure decreasing consistently across pipeline section. It also helps in storage planning because the water storage capacity increases from time to time. Water systems allocate costs evenly over time. This calculation method really helps to predict the costs that needed at that time. In modeling the waste management systems, geometric sequences are used to speculate the rates of decomposition. It helps to anticipate when the breakdown of biodegradable waste from time to time. Furthermore, this geometric method helps in calculating the energy that produced from the incineration of waste. Both sequences provide a method that emphasizing the resource management and predicting the future needs.
Hi everyone, my name is Putri Zulaika binti Otma Hadi and nometric AA240315. Today I want to present about problem and solution. The part 1, water distribution system, which is use the arithmetic sequence. So my step first, we use the formula of arithmetic, which is Sn equals to n over 2 and times 2a1 plus n minus 1 d. So step 2, substitution and calculation. So n equal to 30, a1 equal to 80, d equal to 10. So saya ambil daripada range yang diberikan dekat dalam PDF. So saya kira first step saya guna formula tu dan saya simplifykan dia, saya dapat 6750 kg. So saya analisiskan benda tu, total waste yang saya dapat tu dia tak exceed dengan facility capacity of number group 6, so which is 720 kilo. So saya adjustkan dia balik. Step 4, saya adjustkan dia balik. First, reduce the number of house. Second, decrease the waste per house. Third, decrease the initial waste. So, the first one, reduce the number of house and equal to 10. So, saya dah Jawapan dia 12,250 kg. So still dia tak exceed dengan 720 kilo tu. Yang kedua, saya reduce to 5 kg, to 5 kg. So saya dapat 4,575 kg. Still dia tak exceed dengan capacity yang saya nak 720. So saya reduce A1 which is decrease the initial waste. So 3,000 saya A1 to 500 kg and D5. So saya dapat 3,675 kg. Final recommended, still dia tak exceed dengan jawapan 720. So saya recommendation final punya kiraan still within 720 kilo. Tapi saya letak possibility n equal to 10, A1 equal to 20, D equal to 10. So saya masukkan dalam formula, saya dapat 650 kg. So this satisfied the requirement under 720. So kiranya yang 14 yang saya buat ni boleh satisfy lah sebab dia kurang daripada 720. For part 2, waste management facility. So yang ni kena guna geometric sequence. So the first problem, model the amount of waste produced each year using a geometric sequence. Second, calculate the total waste produced over a given number of year. Third, assess whether the facility can handle the waste and provide recommendation if necessary. So parameter yang saya dapat, initial waste W1 assume 200 kg. Saya ambil daripada range yang diberikan. So growth ratio R assume 1.2, number of years assume 6 years. So step 2, geometric sequence. So formula for yearly waste, WK equal to W1 darab dengan R kuasa K tolak 1, which is WK means waste in year K, W1 equal to 200 kg, R equal to 1.2. So saya masukkan dalam formula Sn equal to W1 darab dengan 1 tolak R kuasa N per 1 tolak R. So R2 kena more than 1. Then Sn total waste after n year, W1 equal to 200 kg, R equal to 1.2, N equal to 6. So step 3, yearly waste calculation. So using WK equal to 200 darab dengan 1.2 kuasa K tolak 1. Saya buat kira W1, W2, W3 sampai W6. Saya dapat 497.664 kg. So step 4, total waste calculation. Using Sn 200 darab 1 tolak 1.2 kuasa 6 bahagi dengan 1 tolak 1.2. So saya calculatekan dia. Then calculation yang keempat, saya buat 200 tolak dengan negatif 1.985984 per negatif 0.2. So sama dengan 200 darab 9.92992. So equal to 1985.984 kg. So step 5, facility capacity assessment. Tu group kita orang 720, which is group 6. So total waste produced in 6 year 1985.984. So since jawapan saya macam tu, dia lebih besar daripada 720 kg. So the facility can handle the increasing waste over 6 years. So step 6 recommendation I3, expand facility capacity, waste reduction initiative and short term solution.
The discussion is from a part of our discussion, the water distribution system. We have a tank holding 720 liters, allocates water to n house in arithmetic sequence. The first house receives the most water and each subsequent house receives a fixed amount less. To ensure the total distribution does not exceed 720 liters, careful calculation is necessary using the arithmetic series formula. However, this model raises concern about fairness and practicality. the disparity in water allocation can become significant, especially with a large number of houses or a steep decrease in the water amount. Common difference. The first house receives more, while the last may receive little or none. To address fairness, the system could be adjusted based on need or recalibrated to respond to change in demand. Similarly, the waste generated by the resident is expected to grow over time due to population growth. Following a geometric sequence, each year, the waste increased by a fixed ratio due to rising consumption. This model helps predict future waste output and in better planning for waste management. However, as the population increases, waste could strain the current infrastructure. Developing more efficient processing method, recycling program or waste reduction initiative is ensured to ensure sustainability and meet the growing demand in the future. Proactive measures will help mitigate environmental impact and ensure the system's long-term effectiveness. Okay. Masih.
Assalamualaikum and hi, my name is Anisha Rika binti Muhammad Nafi, AA 240341. In this case study, the analysis of water distribution system and waste management facilities has been successfully modeled using arithmetic and geometric sequence. With this, we strive to create an equitable distribution of water across households while maintaining the total water consumption within the tank capacity. The geometric sequence effectively projects the increase in waste production over time and enable to estimation of facility requirement. Through this calculation, we discover how mathematically modeling helps in optimizing resource allocation and planning for future demand. The result highlight the need to adjust parameters such as water distribution rates, tank capacity, or water management capacity to ensure sustainability and efficiency. Overall, we found that the combined use of arithmetic and geometric sequence effectively models water distribution and waste management requirements for residential projects. Both systems require careful selection and adjustment of parameters to maintain efficiency, fairness, and sustainability. To improve the capacity, efficiency, and sustainability of the water distribution system and waste management facilities, several measures are recommended. For the water distribution system, increasing the tank capacity is important if the total water demand exceeds the current tank capacity. Other than that, we recommend investing in technology such as waste-to-energy system or anaerobic digestion to process waste more efficiently while generating energy or being usable. Next, for the waste management facility, expanding its capacity is necessary to handle the growing waste volumes over time. Introducing waste reduction strategies such as promoting recycling, composting, and waste segregation and can minimize the amount of waste processed by the facility.
So as you can see here, this is the appendix of our group. We are discussing about the solution and also some of the content of our PBL.